Morning, students. So for the late start. So I think we're gonna have to move fast today. Alright. So I want to work to the paper we did yesterday. And you are to grade yourselves, learn from your mistakes, and correct any mistake you made, redo the questions that you didn't get correct. Stuff like that. Alright? And we want to do the next paper. You don't want to be repeating the mistake that you made. This is a 65% pass mark paper. And the one that we're doing the week coming is also going to be a 65% pass mark. We're moving up to, I think, 75% next week. So to move up to 75% next week, you have to not repeat the mistakes that they made on this paper and on the paper that we're going to be doing this week. Then we're doing another paper tomorrow, the other paper, the June paper. We're going to be going through that one tomorrow. And then Wednesday and Thursday is two new papers again, two additional papers again. All right. I look at the time schedule. I might actually do the assessment this Wednesday and Thursday. But I decide, but I'll let you know. All right. So let's just work from the front. Okay, move rather fairly quickly. Let's just work from the front. All right. So let's go. Number one. Number one is said. So this one is set a little bit differently, right? It says by rounding each number, we follow instructions. In the expression, one significant figure, we must calculate an estimate of this. By rounding each figure, one significant figure. So you can just get the question and just put that in the calculator and work it out, you know. Following instructions. So anybody who did that, you're not getting the marks. So if you correct each figure to one significant figure. So this 108, one significant figure is 100. This is the first significant figure. This 0 cannot change the 1. All right? So to one significant figure, that 108 becomes 100. So it becomes the square root of 100 divided by. Correcting this now to one significant figure. The one significant figure, the first significant figure is the 1. So the 9 is going to increase that 1 by 2. So this number is going to become 20. To one significant figure, it's going to become 20. Plus, you're correcting this number to one significant figure. So the first significant figure here is 5. This 2 cannot increase that 5. So 5.29 to one significant figure is 5. That's first thing. You're ready to calculate now. The square root of 100 is 10. This plus this is 25. So we have 10 over 25. So we can do 5 into this goes 2 times. 5 into this goes 5 times. So an estimated value for this is 2 over 5. Or you can put 0.4. And 2 over 5 is 0.4. Or we could put 0.4. That's what they wanted you to do, to get that 2 marks. Follow the instructions. You see, this one was kind of a little bit different. Most times they say use the calculator and just work it out. No, not this time. Our next one says, find the exact value of this. Okay, use the calculator. I must give the answer in simplest form. Can use the calculator. So I'm going to type this in the calculator exactly as it appears there. So it's going to be a mixed number to start, which is 3 and 3/5 divided by bracket upper fraction 5 over 12, and you're adding another fraction 1/3.
So it's 3 and 3/8.
3 and 3/8. All right, thanks for that. Thanks for that. 3 and 3/8. That's 4.5. And what they say, they want this as a fraction. So it says, give your answer as a mixed number. So we're following the instructions as a mixed number. So it's 4.5 you get. That's 4.5 4.5 is 4.5. 4.5 is the answer. As a mixed number, 4.5. That is it. They want it as a mixed number, 4.5. Right? 4.5 is 4.5. So this is the answer. Right there. All right. So next question. Next question says, due to COVID-19 pandemic, the number of available seats in a hall was reduced from 125 to 93. 125 to 93. 125 minus 93. That's a reduction of 32. Calculate the percentage decrease in the number of seats. So the percentage decrease is going to be equal to the percentage decrease is going to be equal to the decrease divided by the original number and multiply that by 100 to get the other percentage. The decrease is 125 minus 93. The original number was 125. Don't put over 93. It's a decrease from the original number you want. Multiply that by 100. That's what you're working out. All right, so you can put that in the calculator. 125 minus 93 divided by the original 125 multiplied by 100. That's 25.6, 25.6% decrease. What about that? What about that? All right, next question. It says, Micah invests a certain amount of money in a bank and pays compound interest. So compound interest, remember, it's interest paid on whatever the balance is there at the time when the interest is calculated. All right? It says at a rate of 2.5% per annum. So that's the rate. It says at the end of 2 years, the value of the interest becomes this. So this is the final value of after it is compounded for 2 years. All right? It says calculate the amount invested. So basically the original amount that was invested. That's what it is. And they're helping you. They give you a formula right here for compound interest. This is the amount accumulated on a principal of P at a rate percentage of R for a time of N years. N is the number of years, and I tell it here. So A is the total amount after N years. See, N is the number of years. P is the principal amount. So this is what we're trying to find in this question, the P. And the amount accumulated is A. All right? That's compound interest formula. Amount after N years. So in this question, we're trying to find the P. So we're trying to make P the subject. All right? So if you have A equals P times 1 plus R over 100 raised to the N. And this example, let's put in the values. The amount accumulated, they tell you, is this. It is $7,564.50. Let's put dollar sign on it. The percentage is 2.5, and this 100 already takes care of the the percentage in the 2.5. So the R is 2.5. And the time, the N is 2 years. And we're trying to find the P. The P is what we don't know. We're trying to find the P. So we need to make the P the subject. So to make the P the subject, we can take all of this expression and divide it under the A to leave P as the subject. Just divide everything there under the A. Simple as that. So the P, this P, is going to become A over all of this goes under here. 1 plus R over 100 raised to the power N. And that's what we calculate. Just put the values in there and we make this a little smaller. All right, so let's plug the values we know in there and we have the principal amount. So the amount invested, the amount at the end of it was 7,564.50 divided by 1 plus, that's 2.5 over 100 raised to the power 2. Put that in the calculator and give the amount accumulated as in dollars. So the fraction on top there we have 75. Let me show you. I'm typing this exactly as it is in the calculator right here. So 7564.50 over bracket 1 plus fraction 2.5 over 100, those brackets, raise that to the power 2, so you square it. That's $7,200. $7,200 is the amount invested. Simple as that. That's the answer. But go to that, but should get 9 marks on that question. It's very easy. Anything you didn't get right, you need to go and redo it. All right, let's continue. Next question. Simplify these things. Simplify this. So this is the same as x cubed times x cubed. But when you raise an indices to a higher power, you cannot multiply the powers. You can multiply the powers. So this is equal to x to the 3 times 2 equal to x to the 3 times 2, which is x to the 6th power. Or we could write it as x cubed times x cubed times x cubed. That's what the square means. And then when you multiply this with the same base, you add the powers. So it will become now x to the 3 plus 3. I'm showing you another way to do it. X to the 3 plus 3, which then still is x to the 6th power. So either way, the answer is the same, x to the 6th power. Next question. Here again, you are now dividing indices. When you divide indices, you subtract the powers. Note that this one is negative, so you have to be careful with the negative. That's going to become y to the 8 minus this power is negative 5. Because when you divide indices with the same base, you subtract the powers. So it becomes it becomes y to the 8 plus 5, which then is y to the 13 power. That's the answer, y to the 13 power. Want to go to that? Next one. Factorize this. That's just 2 terms. I say a minus, I'm thinking the difference of 2 squared. We must always do common factor first when it exists in the expression. Common factor is a y. So I'm first going to factorize out the y. Y out of this leaves me with an x. Y out of this leaves me with a negative y. That is it. This thing you can't factorize any further, so you stop. And this one now is the difference of 2 squared. You must recognize that that's the difference of 2 squares. So it becomes the difference of the numbers times the sum of the numbers. The difference of the numbers times the sum of the numbers. Hold on a second. Yeah, series of that. Do this over. Right, so become the difference of the numbers and the sum of the numbers. The difference of the numbers is x minus y. Sum of the numbers is x plus y. That's a factor of the difference of 2 squares. Easy like that. Next part now says hence. Hence means that we must use these results. That's what hence means. Use those results. Use the results from part 1 to finish part 2. And these are the results from part 1. So what we have down here, you notice, we have the same expression up here that we factorize at the top. And we have the same expression down here that we factorize at the second time. So we're going to use those same 2 factors. So the numerator becomes y into x minus y. That's what we did when we factorize this initially. The denominator becomes x minus y. This denominator becomes x minus y times x plus y. And then what happens is that this x minus y cancels this x minus y. And you're left with y over x plus y. That's the answer. Y over x plus y. y over x plus y. That's the answer. Nice and easy. Y over x plus y. Right? Next question. Next question said, the diagram below shows two rectangles, M and L, M and N, with their dimensions expressed in X. So dimensions on M is this and that. The dimensions on N is this and that. All right. So I'm observing that this and this is the same. X minus 3, X minus 3 is the same. It says, given that the difference of the two areas is 64, show that this expression is the result. The difference of the two areas is 64. So we need to do, write an expression for the difference of the two areas, put it equal to 64, and then reduce it down to this. That's what's going to happen. All right. So what this basically is saying, this statement says, is the area of M minus area of N is equal to 64. That's what they have said. So we need to write out that in terms of the X and the Y. Now the area of M is this times this. That's X minus 3 times 3X plus 4. That's the area of the M. Minus, area of the N now is X minus 3 times X plus 2. X minus 3 times X plus 2. That's all equal to 64. So now you have various ways you can solve this. You can either expand this out and expand that out and then subtract them. Or you can recognize the X minus 3 as a common factor and factorize the X minus 3 first. But after you factorize the X minus 3, you still have to expand again because it's an expanded form in the final expression. All right? So we can just maybe expand the two sides and then subtract the like points. All right? So whichever way we decide to do, the results are going to be the same. So let's say we're going to expand this side first. So let's expand this double bracketed term. Remember, it is the first term times the first term, which is 3x squared. Then the middle term is the far product and the near product. That's the middle term. We expand those things. The far product and the near product. The far product and the near product. I'm doing it a shortcut way. I'm going to show them in red. So the near product is minus 9x and the far product is plus 4x. So the minus 9x and the plus 4x is minus 5x. So the middle term is minus 5x. Then the last one is the minus 3 times the 4 become negative 12. That's what you get to expand that bracket. Minus, when expand these two now, but you're subtracting everything, so careful with minus. So expand that side near now. So again, it is this time, this is x squared. X times the x is x squared. Then the middle term again, we get the middle term. Again, it's a far product, the near product, and the far product. The near product is minus 3x, and the far product, I'll just set it up around. The far product is this. X times is 2. That's 2x. X times 2 is 2x. So 2x minus 3x is negative x. So the middle term becomes negative x here. So. And then minus 3 times 2 for the last term is minus 6. And that's equal to 64. Let's subtract the like values now. So remember, I know everything in here minus everything in here. I'm here for the negative sign. So it's 3x squared minus x squared give me 2x squared. Let me see it, that's 2x squared. And it's minus 5x minus and negative x. That becomes minus 5x plus x. If you want to expand this out first, I'm going to step by step. That's fine. Let me go step by step and show you. So let's expand out this one with the minus. So it's going to become 3x squared minus 5x minus 12. Expand this now. Minus x squared first. Then it's minus minus a plus x. This minus makes that a plus 6. I can bring over the 64 now and put that minus 64. That's all equal to 0. They combine the like terms now. 3x minus 2x, 3x squared minus x squared is 2x squared. Then this, you're adding this and this now. It's minus 5x plus x is minus 4x. They are the numbers now. That's this, and that. So the minus 12 and the plus 6 is that's minus 6. And the minus 6, minus 64 becomes negative 70. So these numbers come negative 70. Negative 70 equals 0. And then each of these can be divided through by 2 to simplify. So we're going to divide through by 2. We divide each term by 2. You divide this by 2, it becomes x squared. Divide this by 2, it becomes minus 2x. Divide this by 2, it becomes negative 35 equals divide 0 by 2, it is still 0. That's what they told us to show. So that is no 4 marks to do that. But God, that is it. They don't want you to solve it, just show it. They didn't ask you to solve it, so don't solve it. Just work it out, and that is it. All right? So that's just some algebra. Good. Next question. Come to this question. So the question said, the following diagram shows 3 quadrilaterals, P, Q, and R, on a square grid. Q and R are the images of P. So P is your original. P is your original. It is transformed to this clearly by an enlargement. Then it is transformed to this. It's either by a rotation or by a reflection. Remember, rotation and a reflection can look alike sometimes. All right? But to make the distinction, you can check the orientation. If the orientation is the same, then you have a rotation because reflection reverses orientation. Put another way. If the orientation is reversed, then you have a reflection in a line. Reflection in a line is the only transformation that reverses orientation. All right? The only single transformation that reverses orientation. So naturally, they're going to want us to tell them what transformation take us from this to this and from that to that. That's how this question is going to go for sure. All right? So, see here, it says on the grid on page 9, draw the image of quadrilateral P after a translation of 10 negative 4. So 10 negative 4, 10 negative 4, 10 means 10 to the right, and the negative 4 means 4 downwards. That's what 10 negative 4 means. So you're going to move P 10 units to the right and 4 units downwards. That's for part A. And I want us to label that one P prime. All right, so let's go and do 10 to the right, 4 down. This one. And we can just move 1 point and just draw by the same shape around that 1 point. Because translation don't change anything on the object. It's the same. Just changes its position. All right, so we're going to move this point 10 to the right. You must always check the grid if each of this is 1 unit. Yes, it is. And also vertically, it's 1 unit. Yes, it is. So check the grid, make sure it is 1 unit. Oh, I know it's 1 unit because here will be 1. So 0 to 1 is 1 unit. And here will be 3. 3 to 4 is 1 unit. So each grid is a unit. I want to move this 10 units to the right, 4 units down. So see it here, starting from this point. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here, and you could do it another way by adding 10 to negative 7. If you add 10 to negative 7, it's going to come over to 3 right here. All right? That's another way you could have done. Then now you need to go 4 down. 1, 2, 3, 4. That's right here. So it means that this point is coming to right here after the translation. And I'm going to draw by the same shape around that point now. So we have this diagonal first, which is across here. Then we have this diagonal, which is across 2 boxes, as you can see. It's coming down to here. Draw this one with a straight line. You have this diagonal over this side, which is going to put right here. And you complete the shape like that. And then I must leave it P prime. And that is the translation. 10 to the right, 4 down. 10 to the right, 1, 2, 3, 4 down. That is it. But go to that. But okay with that? All right. Nice and easy. Next thing I want us to do is the reflection in the line y equals 0. Now, the important thing with this one is for you to recognize that the line y equals 0 is actually the x-axis. Line y equals 0 is the x-axis. So I want it to reflect in the x-axis and label it p prime, p double prime. All right, so we're actually reflecting in the x-axis, this thing in the x-axis. So the x-axis is this line, as you know. And again, when you do reflection, do it 1 point at a time. Image distance equals object distance. So this point, for example, is 1, 2, 3, 4 to the mirror line. It's going to go 4 on the other side. 1, 2, 3, 4. That point is coming here. And this point at the top is going to go 6. No, 7. It's going to go 1, 2, 3, 4, 5, 6, 7 to the mirror line. It's going to go 7 on the other side. 1, 2, 3, 4, 5, 6, 7 to here. That's a point at the top coming there. And then these 2 points come in the same distance to the mirror line on either side of that thing. So this one is what? 1, 2, 3, 4, 5, 6 to the mirror line. It's gonna go 1, 2, 3, 4, 5, 6 to the other side to here. Another one is doing the same thing to the other side to here. So those are the points of my shape. Do the transformation 1 point at a time to the shape, and then you draw the shape around those points. So this diagonal, this one, and then that one. And label it P double prime, P double prime. That is it. All right? That is it. So far, so good? So far, so good? Next part so says now, describe fully the transformation which maps P to Q. P to Q. P to Q now. So going from this one to this one. Clearly it's an enlargement. An enlargement has 2 components. An enlargement has 2 components. It has a scale factor and a center. So we can look at it and know what the scale factor is. So for example, this line across here was 2 units long. Corresponding line across here is all long. 1, 2, 3, 4, 5, 6. So this was 2, this has gone to 6. That's a multiplier of 3. Means that the scale factor is 3, just by looking at that. Scale factor is 3. We use another side if you want it. So for example, this diagonal is 1 unit. Corresponding side is 1, 2, 3 units. See? From 1 to 3. Again, you multiply by 3, so the scale factor is 3. You know the scale factor already. Next thing you want to find is the center of the enlargement. So the center of enlargement is on the line joining corresponding points. So the 2 easy corresponding points are these 2. So you know the center of the enlargement is on this line, joining them. Right? That line. They need 2 other corresponding points like this one and this one. So you can do the same thing again, draw the straight line through them. And then it's a matter of extending it back. So it looks like, draw some good. Looks like this is the center of my enlargement. So I want to make sure. So I can check if the scale factor of 3 also affects distance. Remember, enlargement also affects distance from the center point. It affects the size of the object, but also affects the distance. So the scale factor is 3. The distance from this center point to the object is tripled. So for example, this distance is supposed to be tripled. That's 3 units. It's supposed to go to 9 units. So this distance here, so it's 3 units. This distance to here is 3 units right now. Corresponding distance is that one out there. So is that 9 units? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. That's telling me that that is the correct center of the enlargement. All right? That's telling me that. So that's the center of the enlargement because it affects the distance as well. I feel like you can try another point just to make sure. But that clearly is the center of the enlargement. What point is that? What point is that? That point is -10, 7. See it? It is 7. See it there? 7 is the y value there. That's -10, 7. -10, 7 is that point. So that's the center of the enlargement. So we can write this shape now. You know the scale factor is 3 and the positive 3. How is the positive 3? And the image of the object pointing in the same direction. See? Like for example, this point pointing down on the object and the image that one pointing down. And also they are both on the same side of the center. Both of them are on the right side of the center. That's how no scale factors are positive 3. All right? So we can write the description. It's an enlargement of scale factor 3 about the center point, -10, -10, 7. So this is an enlargement of scale factor -3 about, I can say, scale factor -3 and center -10, 7. Done. You could say also about the point -10, 7. So the scale factor is -3 and the center is -10, 7. That's all I want. You give them the name, give them the name of the enlargement, and you give them the component, the scale factor, and the center. That's all I want. Next one is from quadrilateral E to R. So now we're looking at from this one down to that one. And we have to use the process of elimination. So I know it's not a translation, because translation don't change anything except position. It's also not an enlargement, but the size is the same. So it's either a rotation or a reflection. You want to check if it's a reflection by checking the orientation. Or they didn't give us any point on it. We can put some points on it to make sure. Right? So we can call, for example, over here, so A, call here, so B, call here, so C. Up here to be A, B, C. Down here be D, D. So the orientation of this one is clockwise. Orientation of this one is also clockwise. So you know that the orientation did not change. So it's not a reflection, it's a rotation. So you know it's a rotation. In order to know it's a rotation, you have to know the 3 components of rotation. Young side, put on the phone a little bit now. Angle, direction, and center. For a rotation, I have to give the 3 components. Angle, direction, and center. So we know it's not a reflection because orientation did not change. All right? So we have to know now for the angle of rotation, I take these off. Give that center point. So comparing these 2 shapes now, these 2. All right? This to this. All right. Firstly, we can take one side. This piece that was pointing down is now pointing this way. So that is turn up that way and start to point. So see that? See that? So that's an anti-clockwise. Firstly, it was vertical first and went horizontal. So that's a 90-degree turn. And it was pointing down, and now most of it seemed to be pointing this way. So rotate that way. It's anti-clockwise rotation. What is that? That's the first thing. So the anti-clockwise 90-degree rotation. So the next question is the center. How do you find the center? Most times the center of the rotation is the origin. This question, but this one is not the origin. One was not the origin. Because if I try to test the origin at the center, right? By using a current 1 point. Let's say we go from this point to this point. If the center was the origin. Remember, I know I'm saying it's supposed to be a rotation of anti-clockwise 90 degrees, right? So we could work out the coordinates to this point, like horizontally and then vertically. If I rotate this thing 90 degrees anti-clockwise, then this horizontal piece will come down here, so. And this piece at the top of it will go across here, so. And that's not, oh, sorry. And that's clearly not where this point has gone. So you know the center is not the origin, just by doing that. Okay, test what? Test which will rotate the coordinates, this line to this line, anti-clockwise 90 degrees. This piece would have come down here. Oh, this would have been on the other side. It would have been on the other side. And then the head of it would have been over here, which is still not where this is. So, you know, it's not an anti-clockwise, not about the center rotation, is not the origin. Well, I can tell you from now, guys, it's a special question. Why is it special? Because it is very rare that the set of question where the center of the enlargement is not the origin. Hello? Hello? What's up? Oh, cool. Again, what's up with the and class? Sorry about that, guys. Right. So I'm saying this is a special question because if about 30 years, CSEC did not set a question where the center of rotation was not the origin, or the center of rotation had to be constructed the way I'm going to show you now, which is a way that I showed in class before. Right? So it's a rare case where you had to use this construction method to find where the center of rotation is. And you have to basically make sure you understand it. So the key thing is that the center of rotation is on the perpendicular bisector of the lines joining corresponding points. I need two of them. So you need two perpendicular bisectors of lines joining corresponding points. So you have to construct it. All right? So you have to find the corresponding points first. And you want to kind of be convenient. You want to use points that are convenient to you. So like this and this are corresponding points, right? This and this are corresponding points, those two. This and this are corresponding points. And then you have this and this corresponding. So if you want to be, if you're not sure, you can label it up. But imagine say rotate it up horizontal that way. How it would look. Right? So you basically stay like so. Like what this is. Right? So this point would have gone up here. So this corresponds to this. This point is at the back. So this corresponds to this. And this point over here is at the bottom. See that? Under here. So these are two corresponding points. I'm going to use those two because those two are convenient to use. So I'm going to join those two first. And I need a perpendicular bisector of that line. The center is on the perpendicular bisector of that line. But draw the perpendicular bisector and use purple. So you find the midway point on this line. 1, 2, 3, 4, 5, 6, 7, 8. The halfway mark on that line will be 4. 1, 2, 3, 4. So this will be the halfway mark right here. So you need a perpendicular to that vertical line. The perpendicular to that vertical line is this horizontal line. So the center is on this line somewhere. That's the first perpendicular bisector. of line join the corresponding points. Then I can join this one and this one. I can now join these two if I want. This one and this one. Or I can join this one and this one. Your choice. Let's say we use this two. This one and this one as corresponding points. Let me join them with this line. I need a perpendicular bisector of that line now. So I need to find a halfway mark on that line. All right? That line is so friendly because this horizontal is not a full unit. Let me use another one. I'm sure I use it in case that's what they use. So one halfway mark on that line. You could actually put your ruler on it and find a halfway mark if you like. But you can count out the coordinates. So watch this now. The length of this line can be broken down as 1, 2, 3, 4, 5 down and 1 across. So the halfway mark will be 2.5 down and half across. 2.5 down, half across. Look again. The length of this line can be broken down as 1, 2, 3, 4, 5 down, 1 across. So halfway will be half of the 5 down, which is 2.5 down, half of the 1 across, which is half across. Right? On the line. So the center of this line, the midpoint of this line will be 2.5 down. 1, 2.5 down, half across, half across. So the midpoint of this line is around here. What I need now is a perpendicular line to this. I need a perpendicular to this line now. So the perpendicular to this would maybe look like about that. Let's try it again. So you can actually put your protractor on it like so and get the perpendicular. I want a 90 degrees. You can use a protractor, put it on it, and get the perpendicular to here if you want, right? But it looks to me like it will be around this. Somewhere there. Which is telling me that the center of the rotation is looking like this point. That's the center of the rotation. I'm going to test it now. That is actually the center of the rotation. I'm going to test it. All right? Let me use the blue ink and show you how we test it. Which I am saying. Hey, outside man. Huh? I say pay attention with the head down on the thing there. Let me get stop from class, you know. Pay attention. You can learn by not paying attention. That's about talk to you about stop from class. I waste some other money. So look here now. You draw a line to here. And you draw a line to here. This angle is supposed to be 90 degrees because like it rotated 90 degrees around to here. See that? This angle is actually 90 degrees. See that? That's showing that that's the sector. Try another point. Let's say we use it this point up here down to this point over here. Again, that is 90 degrees. You see it? So again, you can see that the rotation around here is 90 degrees. So that proves that the center of rotation is this. But I understand that. But I say that. So I'm going to leave these two under there. This one to this one. So this rotation is 90 degrees. And that's the center point. And that point, that point is a point negative 4, 2. The center point is negative 4, 2. Negative 4, 2 is that center point. You have to remember the sketch that. And if you go home, do it over again. All right? Do it over again. Print out the page and do it over again. All right? Negative 4, 2. You have to remember this process. Watch over the video. Try it over yourself because this don't come often. If you come on the exam, you want to be able to do it. All right? You want to make sure you know to do it. So this becomes the anticlockwise, we said, right? Or the thing turn up that way. So this is an anticlockwise. -90-degree rotation. About the point negative 43. So for the rotation, we give the name and the components, the angle, the direction, and the center. Remember, the anti-clockwise rotation could have put positive 90 degrees as well. Could have instead said positive 90 degrees rotation. Because anti-clockwise rotation is positive. So you could have said a positive 90-degree rotation. They would have to accept it. Anti-clockwise rotation is positive rotation. Clockwise rotation is negative rotation. Question done. But all right, Michelle, what's the matter with you? Huh? They pay attention, boss. You're not paying attention. Pay attention. I'm not calling about after one to you. You clearly have a problem. Pay attention. You can't pay attention with your head down, my boss. If you're not going to be interested in pay attention, but come here to try and learn something. You don't make sense. And not in the foolishness. All right? If you have a problem, start it out. You come class, prepare to do the work. Next question. Other people having problem with this. You're not supposed to have any problem with a question like this. You're supposed to be happy to see a question like this. These graph with lines. Because I can do this question without a lot of calculation because the information is there on the graph. You can count out the gradient and you can see the y-axis intercept. That's the beauty about when you get lines on graphs. And that's what you need for the equation. The y-axis intercept and the gradient. You don't have to do a lot of calculations when you have the lines on the graph. But the information that you would normally have to calculate, you can just count it off on the graph and see it on the graph. Let's go. Question says, L and M are shown on the square grid. It says, write down the coordinates of the x-intercept of L, where L is. So they're asking us for this point. That point is 6, 0. Remember, I put the x value first. So L is the point. The x-axis intercept is 6, 0 on L. Simple as that, 6, 0. The y-intercept of M. So M here, y-intercept is right here. Remember, I put the x value first and the y value next. That point is 0, negative 2. 0, negative 2. It don't make sense to lose those marks, you know, they're too easy. X-intercept and y-intercept. All right? On the x-axis, the y value is 0. See, the y value is 0. On the y-axis, the x value is 0. See, the x value is 0. The question says coordinates, and we put both of them. You can't put 6 for this one, and you can't put negative 2 for this one. The question said coordinates. Coordinates are written like that with the bracket, and you put the x value and the y value. That's how coordinates are written. Anything other than these is wrong. Anything other than these two things is wrong. Pay attention to the detail. It's asked for the x coordinates, and the x-intercept and the y-intercept. So we give coordinates, the x value and the y value. All right. Next question. The equation of line L is this. Tell us the equation of line L. It says find the value of k at the point 9k on line L. So all you have to do is find the value of k. One, you can do it from the graph, because basically it's where the line passes through where x equals 9. Or you can plug the 9 in the equation and see what the y value come out to be. Whatever the y value come out to be is a k. Right? So you can get it from the graph, you know. At this point, the x equals 9. At this point, the x is equal to 9. So you can look at the graph on this line L and see what the y value is at that point where x equals 9. Look at the graph. You can do it that way. So you can look at the graph, see the graph here. X equals 9 right out here. So see the line here now, L we're talking about. X equals 9 right here. So this is the point that I'm talking about. That's 9 something. What is that value? That looks like negative 1.5 to me. See it? Negative 1.5. That looks like negative 1.5. Negative 1.5 or negative 3/2. That's what it looks like to me if you go and use the graph. But because it come in the middle of nowhere, I don't like that. I like when it pass through these grid values, these grids. They can know the value exact. But that's what it looks like to me from the graph. I'm not going to calculate it now and see what we get. All right? So you do by calculation. You plug the coordinates into the equation because the coordinates satisfy the equation. So you plug the values in the equation. So I'm seeing y equals negative, it must be 3.5. What you say, what? Negative 1.5, right? Just show over 2. But I'm going to use the other method of plugging the values in there. So it's 9 negative k, 9k, not negative k, 9k. I'm going to take the 9 and substitute it here so for the x, and take the k and substitute it here so for the y. That's what I'm going to do. It's a point on the graph. All right? And I'm going to get that 9 plus 2 times k minus 6 equals 0. When I plug those values in there. So I need to find this x. So first, the 9 minus 6 is 3. So I'm going to get 2k equals 2k plus 3. 2k plus 3 equals 0 first. But the 9 minus 6 is 3. I carry over the 3 and get 2k equals negative 3. Then divide by the 2. See there? K equals negative 3 over 2. That's the answer. Same thing we got. Y value is that. Right? So therefore, K negative 3 over 2. And this one is from the graph. From the graph. So I've gotten it from the graph. This one is by calculation. Same answer. Negative 3 over 2. Small shit stuff a little bit. All right. Just substitute the point, the coordinates into the equation. Next one says, find the equation of line M in the form y equals mx plus c. Line M in the form y equals mx plus c. So when we work on line M on the graph, we don't have to calculate now because we have the graph. You can count off the gradient and see the y-axis intercept on line M. And line M, this is line M. All right, let's go. So firstly, on line M, this is the C value. Man, I need to find a way to get that back screen. I don't know. This is the C value on line M right here. So right here, the C is equal to negative 2 on line M. They want the gradient. To get the gradient, you want to find the rise and the run, right? So let's say we're using any 2 points on the line M I want to use. 2 points that you know the coordinates for sure. Let's say we're using this point to this point. So this point to this point. You count the rise and count the run. From that point to that point. What is the rise here? So the rise here so it's 2 units. So rise 2. And then this is 1 unit. You run 1. Right? So the gradient of line M is rise 2 over run 1. 2 over 1 is 2. So gradient of line M is 2. And the y-axis intercept is negative 2. So that rise 2, run 1. Line M we're talking about. So we're going to do that down here. So down here, let's write it. The gradient is rise 2 over run 1, which is equal to 2. And the C is negative 2. Therefore, the equation is y equals the M is 2 times x, that's 2x, and the plus C is negative 2. So we're just going to write minus 2. That's the answer. 2x minus 2. Next part now says, show by calculation that line 1, L, and M are perpendicular. If they're perpendicular, then the product of the gradient is equal to negative 1. We already know the gradient of line M is 2. So put a little capital M on here. So the gradient of line M, we already know is 2. We're going to work on gradient of line N. I'm going to graph and count it off, and I've calculated, just count it off. This one is line L, not N, not N. It's L. L. L is the next one. L. Let's go on the graph and count out the gradient of line N. I can use any 2 points. Let's say we're using these 2 points. This to this. That to that. This way. The run, can do the run first, don't matter. The run is 2 units. And the rise is -1, can go down. So the rise is -1. So it's rise -1, run 2. You could do the rise first. Don't you see we could do the rise first, -1, and then run 2. Same thing. Don't matter which one they put first. I know you put the rise over run for the gradient. So the rise is -1 and the run is 2. So come down here. So for the line, the second line, line L, the rise is -1 over the run is 2. -1 over 2 is -1 over 2. Then we multiply them. The gradient of line M multiplied by the gradient of line L comes 2 times -half. That's equal to -1. When the product of the gradients equal -1, it means that they are perpendicular. That's what I'm saying, show by calculation. So you have to know this. You have to know that when the product of the gradients is -1, they are perpendicular. This means that they are perpendicular. Therefore, L and M are perpendicular. Because when you multiply the gradients, you get -1. That's what happens with perpendicular lines. The lines that are parallel, they would have the same gradient. Perpendicular lines have negative reciprocal gradient, such that when you multiply the gradients, you get -1. All right. Next one says the line L and line M represent the graph of a pair of simultaneous equations. Using the graph, write down the solution to the pair of simultaneous equations. The solution is the point of intersection. The solution of a pair of simultaneous equation is the point of intersection. The point of intersection. So when you solve simultaneous equation, that's what you're actually finding. Point of intersection. And that is, let's look on the graph and see what it is. Where they intersect each other. They intersect each other at this point right here. See it here, so? What the coordinate at that point? 2, 2. That's the intersection. That's the question. So the intersection represents the solution for the simultaneous equation. That's 2, 2. So they intersect at the point 2, 2. That's the answer. Done. Very good. And if you get wrong, go and do it. Solution for a pair of simultaneous equations is the point of intersection. All right. Next question is a statistics, number 5. It says cumulative frequency curve below shows information about the times taken by 200 students to solve a math Olympiad problem. So the 200 students, that's 200 students. So these are the students. The ones who took the shortest time are down here. The ones who took the longest time are up here. And these are the times that they took less than or equal to. Remember, the graph cannot show you the actual time that they took because they don't have that information. Once you see a cumulative frequency graph, it's either a less than time graph or a less than or equal to time graph. As soon as you start with the question, you see what kind of graph it is. Is that a less than graph or a less than or equal to graph? When it's a less than graph, they use the upper boundary values against the cumulative frequency. When they're less than or equal to graph, they use the upper limit value against the cumulative frequency. All right? Question says, use the cumulative frequency above to find an estimate for the number of students who took more. So I'm just say more, you know, so that less than or equal to graph. Because the graph is going to show you how many people took less than or equal to 50. The rest of them took more. So I know that that's a less than or equal to graph just by that question. They asked me for how many took more than 50 minutes. Because they know that the graph is going to show me how many took less than or equal to 50 minutes. You understand? So the graph is going to tell me how much took less than or equal to 50 minutes. The rest of them took more. So let's look at it. So that's what this means. So this is a less than or equal to graph. I know that right away. It's a less than or equal to graph. Less than or equal to time. That's what it's showing. So I want to know how many people took more than 50. More than 50 are the people out here, so to the right. The graph is going to show me how many people took less than or equal to 50. So you're going to come at 50, come up on the graph at 50, and read it up on the graph right here. So. Right? And then you come across here. I'm going to read that value. Before you start to read, you have to establish a scale of the graph. So I've got that first. You want to know what every little one of these intervals mean on the graph. All right? That's a millimeter. So horizontally is 1. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So every interval horizontally is 1 unit. So you can put that here to remind you. But vertically, it is 5 intervals. Either 1, 2, 3, 4, 5 intervals up to 20. So each interval is 4. I divide the total of 20 by the number of intervals. So each one is 4. So each of these represents 4 students. That's 4 students. So it means then that up here is 4 below 200. Because this interval inside it says 4. So it means that right here says 96 is 196. So 196 took less than 50. The rest of them took more than 50. So it's 4 of them took more than 50. That size 4 students. So let's go down there. And let's connect back to 50. So see here, the 50 on the graph corresponds to 196 students. So it means that 196 took less than or equal to 50 minutes. So the rest of them, of the 200, took more. All right, so let's put it down here. So see here, 196 students took less than or equal to 50 minutes. Therefore, 4 students took more, greater than 50 minutes. Which is what this is asking us. Who took more than 50 minutes? That's what that means. So the answer is this. This is the answer right here. 4 students. This is the answer. 4 students. This is the answer. 4 students took more than 50 minutes. But understand that? 196 took less, a total of 200, so 4 took more. Next question. The median time taken to solve the problem. So the median time taken is the approximate time taken by less than half the number of students, which is 100 students. So the portion of the median is 100 students. You find the time taken by the 100 students approximately, and then that's the median time. So you're gonna go for the position of the median is the 100 student right here. This is the position of the median. This, right? That's the position of the median. So we're gonna say position of Q2. Position of Q2 is the 100 student, half of the 200. You come across on a graph and you read that down. You come across on a graph and you read it down here. So like right in between this, so that figure is Q2. That is, each of these is 1, right? That's 31, 32, 33 and a half. 33.5. 33.5 minutes. 33.5. Q2 is 33.5. So based on the graph, I'm going to write 33.5. So based on this, Q2, the median. Q2 is 33.5 minutes. Are you good? Simple as that. Next question says, the probability that student chose at random took at most 28 minutes. At most 28 minutes means that 28 minutes is the most. So at most 28 minutes means less than or equal to 28, means 28 or less. At most 28 minutes means less than or equal to 28. So you want to know how many students took less than or equal to 28 and they divide that by the 200 to get the probability of one of them. See that? All right? So let's go on. So first we're going to get the number of students. The number of students for less than 28. Let me do it this way. Probability of being less than or equal to 28 minutes equal. We're going to put the number of students over 200. So how many students took less than 28? Less than or equal to 20. Let's go up on the graph to 28 and see how many the graph give us. The graph will tell you how many that is. So when I find 28 now, 28 there. 28 is right here. This is 28. 28 minutes. Come up on the graph and read off 28. 28 taking us right up to here. I'm going to come across to here. That's 64 students, eh? 64. This is 64. See that? So 64 out of 200. 64 out of 200. So 64 students took less than that time. So 64 out of 200. What are we doing to? 64 over 200 is a what? 64 over 200 is 0.32. The simple fraction that is 8 over 25. That's 8 over 25. That's 25 is a short. That's the answer. But God, I see all those lines I drew on the graph, I'm leaving them. So CSEC saw where my 64 came from. As I'm leaving all those markings on the graph right here. 64 right here, I'm leaving it there. The 28 down there, I'm leaving. I believe all those markings to show where you get them. 61 to say you get your values. All right? So leave them on the graph. Next question says, using a cumulative frequency curve on page 13, complete the table. So we need to fill out these cells. So we need to know the value frequency per here. In other words, how many students are in this interval. If you realize that this is the interval between 10, remember, you know, the graph goes from boundary value to boundary value. So this is the interval between 10 and 20. That's what this interval is on the graph. Remember, the graph is using the boundary value. This graph, because the less than or equal to, is using the limit values. It's using the limit values. So the interval for here, the frequency for here, is the number between the 10 and the 20 because it is in this interval. And this interval on the graph is really between the 10 and the 20. So you want to know how many students is in between the 10 and the 20. And then this one down here is between the 40 and the 50. Right? That's what you want. So here you're looking for between 10 and 20. So you want between 10 and 20, 10 to 20 students. 10 to 20 on graph. And down here, so it's in this interval between 40 and 50. Because remember, they're using the upper limit parts. Here, so it's between 40 to 50. 40 to 50 on the graph. 40 to 50 on the graph. All right. So I want to see how many people between 10 and 20 and how many people between 40 and 50 to fill out this. Remember, everything must then add up to 200 if those values are correct. Everything must add up to 200 the values are correct. Between 10 and 20 first. Between 10 and 20. Let's look at it. Between 10 and 20. Let's do that part in blue. Between 10 and 20. So 10 right here, so 10 come up to here, so go across to here. That's 12, right? 12. But every interval is 4. So it's 3 intervals here, so that's 12, right here. So it's 12 and 20. Come up to here, so come across right in the middle here. But every interval is 4. So this is 20, 24, 28, 32. So it'll be 36, 32 and 36. So between 32 and 36, halfway between 32 and 36 is 34. Right here, so it's 34. Right here, so it's actually 34. So this interval is 34 minus 12 is 22. So in this interval, it's 22 students. Up here says 22 students. Right here says 22 students. Then the interval between 40 and 50 now. We already know what 50 is. 50 was 196. All right, let's put on the interval for 40. So for 40, is right up to here, so. And come across right here, so 40 is a nice figure. The 40 is clearly 196. And, oh, sorry, 160, sorry, 160, between 160 and 196. This interval, that's how much is that? 36 students, that's 36. 196 minus 160 is 36 students in that interval. So this interval is 36 students. 36 down here. What we can do is make sure by adding up all these values that it must come to 200. So we can make sure that the value that we wrote down is correct. Because this must add up to 200. Let's add them up. So it's 12 plus 22 plus 42 plus 84 plus 36 plus 4. Good. 200. So you can have confidence that those values are correct. Because the total is what it's supposed to be. 200. So we can complete the table now. But this is your sum column. F times X, remember, is your sum column. If you are adding up all the values, all the time taken by all the students. So multiply these two first to get this. It is already done. You multiply these two to get this. We don't have it yet, so we need to do it. So that's 15.5 times 22. That's 341. 341. And we have this one as well, 36 times that number. So that is 45.5 times 36 students. That's 1638. You're going to sum of the sum of everything here now to get the sum of the sum. So this right here is the sum of F. This is the sum of F. And then we need the sum of Fx. Add up all of these values now to get the sum of the sum of all the students. So it's 66 plus 341 plus 1071 plus 2982 plus 1638 plus 222. That's 6320. The sum of the sum. That's where I completed the table. Then said no. Use information to complete an estimate of the average, estimate average time. The average time is the mean they're asking you for. The average time they're asking you for is the mean. That's what they want. The average time is the mean, which is equal to the sum of the sum divided by the number of students, which is the sum of F. So it becomes 6320, the total time approximately taken by all 200 students. It works out to be. So dividing this figure by 200, 6320 divided by 200, that's 31.6 minutes is the average time or the mean time. So they put minutes on this. That's the answer. Very good. We never get it, we're going to do it over. Why you run it up? Huh? Did you get this figure? 6320. Huh? And then this give you 32. Huh? What it give you? What calculator give you? You divide that by that and get a value other than 31.6. You say now the calculator right, man. When you're gonna use the calculator, must always clear it. Clear it. Each time you're gonna use the calculator, clear it. Press the clearing button on it, press it multiple times. Clear out everything out of it. Each time you calculate. Each time you want to calculate, getting up with a cancel, clear it. Just press that a couple times and then you calculate. So me what happens is that figure in the memory. So you give it the wrong figure. You understand? Get the habit of clearing the calculator each time. All right. So you learn. That's how the mock exams. So these things happen to you. The mock exams, you learn something to prevent it from the real exam. You get me? Good. All right. That's how the mock exams. So experience these things. This question on number 6. Number 6 says we were to take pi as 22/7. So once you say that, then you're going to be doing some circular measures. Right? Because pi comes into play when you're doing some circular measures, circle calculation. He said the diagram below shows the scale. It's a scale drawing of a running track. It says it consists of a rectangle and 2 semicircles with diameters L, N, that's here, and this, and it is 49. So everything there is on the diagram. So diameter is 49. I'm going to write down the radius. I like to work with radius. So once you're doing circular measures, we tend to work with radius. So the radius is 49/2. What is that? 49/2 is the... Huh? How much? 24.5. All right, so that's a radius, 24.5. And it says this length is 98, and this length is also 98. All right. Question says, show the total length of the running track is 350 meters. The total length of the running track is the distance around here. So basically, it becomes this length plus this length plus a half a circle here plus a half a circumference here, don't it? So you could say it is 2 times 98 plus a circumference. Because the 2 half circles make a circumference. Agree? That's all. Good. Let's do it that way. So that total distance this is the perimeter. Let's just call it perimeter. It's actually the perimeter. We do. It becomes 98 plus 98, that's 2 long sides, plus it becomes 2 pi r, 2 half a circles, 2 pi r, and the r is 24.5. 2 pi times 24.5. Right, what this is? This is 2 pi r. Right here, we're using 2 pi r. 2 pi r because we're doing 2 times half of 2 pi r. That's what happens. But this is the half of 2 pi r. This side is also half of 2 pi r. Half of a circumference. You see that? There's 2 of them. 2 times half of 2 pi r. 2 of them. So it becomes just 2 pi r. Right? Because the half cancel the 2. So you get 2 pi r. That's what this is. 2 pi r right here. Alright? So, and then this up here is 98 as well. Up here so it's also 98. Alright? I'll just put the calculator, this in the calculator. I said the thing is 22/7. So I'm gonna put that in the calculator and see what we get. I get the 350 as I said. Got the pi is 22/7. Right here, so the pi is 22/7. So put all that in the calculator and put 22/7 for the pi. You're gonna get 98 plus 98 plus 2 times 22/7 times the radius of 24.5. 350 flat. 350 flat. So that put in the calculator, I get 350 flat, 350 meters. shown. That is it. All right, the distance around the running track. All right, half of a circumference each arc. Next part says Nathan walks at a constant rate of 1.5 meters per second. This is not complicated. Don't see this thing that's complicated. Yeah, you can use speed equal distance over time if you want, because that's a speed. But you can just recognize that as 1.4 meters each second. 1.4 meters each second. That's what this means. This simply means 1.4 meters each second. All right, but you could use speed equal distance over time, because a constant speed, right? It says calculate the time taken to do 7 laps. So I want to know what the distance is for 7 laps. I want to know the time taken for 7 laps. So 7 laps, what distance is that? 7 laps distance, 7 laps distance. Is 7 times 250, don't it? What is that? 2,450. All right, 2,450 meters. All right. And then now you want to know how long it takes. So divide that 2,450 by the speed. Right? Therefore, the time equal 2,450 over the speed of 1.4 meters. But every second is 1.4. So you want to know how many 1.4 seconds is in this total distance. How many 1.4 meters is in this total distance. That gives you the time in seconds, which works out to be what? So divide that now by 1.4, you get 1750 seconds. And you have to say seconds, and you can also write 1750. You have to give the measurement of the time. You could have divided this by 60 and give it in minutes if you want it. Okay, I'll leave it in seconds. All right? That's the time it took. He said Tafari runs 1 lap in 68 seconds. He does 1 lap in 68 seconds. Determine the number of laps that Tafari can complete in 1 hour. You want to know how many 68 seconds is there in 1 hour? We have converted hour to seconds now, right? See that? So see here now, 1 hour is equivalent to how many seconds? Is 1 times 60 times 60, don't it? Okay, 60 minutes first, and then each minute multiplied by 60 again, right? How much is that? 3,600 seconds. It is over. Huh? Right? Therefore, number of laps is going to be the total time that 1 hour is divided by the time that it takes each lap in. And so it's 3,600 divided by 68 equals, okay, 52.9. So you get 52.9 laps. The question asks you how many laps you will complete. So the word complete, then the other complete 52.9. You will complete 52 laps. That's right, 52. Anytime a question asks for the number of something, you can give a counting number as the answer. Right? So the answer is he completes 52 laps. That is the answer. So if you get this as the, if you get that, that's not the answer. The answer is the number of laps he completes. So 52.9, the 0.9 in now reach one next lap yet. They can't put 0.9. The question asks specifically the number of laps Safari can complete he completes 52 laps. So if you put 59, 52.9, you might just lose a marks for that. Just remember, guys, entire question asks for the number of something, must look to give a whole number for your answer, a counting number. Remember that. Entire question asks for the number of something. Number of something is something that you count, right? So you're counting the laps. So the number of laps completed is 52. In the reach the 53rd lap yet. But finish the 53rd. He's on the 53rd lap. He has completed 52 laps. So the answer is 52. That's what the CSEC is looking for, 52, not 52.9. All right? Next question says, Nathan completes running one lap of the track in 72 seconds. Tafara and Nathan start running at the same time from a point L on the track. Each complete a number of laps on the track. So remember, Tafara is going at 68 seconds, right? Tafara is going at 68 seconds. 68 seconds. So there's a 4 second difference between them. He's going 4 seconds slower than Tafara. So Tafara is going to be doing more laps, don't it? Because he's completing laps in a shorter time, right? So Tafara will be doing more laps. Tafara will do more laps. So Tafara does more laps. You can make a note of that. Tafara will do more laps than him at the same time. Tafara went faster than him. They're doing it in a shorter time. Tafara does more laps. In the same time. All right, so two of them start at the same time from the same place. All right, they start running at the same time from the point L on the track. Each complete a number of laps on the track. So one going 4 seconds faster than the next one, right? It says each complete the number of laps. Calculate the least number of laps that each will complete before they are both at L again. In other words, one will go faster than one, so one gone out in front. So Tafara gone out in front because he's running faster, right? Because he's taking 68 seconds. So he's completing each lap 4 seconds faster than the other guy. So for them to meet again, you want to know how many 4 seconds there are in the total time for one of them to complete a lap. But you can understand that? They are going at 4 seconds difference in terms of time. One going at 68 seconds per lap, and one going at 72 seconds per lap. So when the first one passed the point L, he is 4 seconds ahead of the second one. That's first lap. The second lap is going to be 8 seconds ahead. Third lap is going to be 12 seconds ahead. Fourth lap is going to be 16 seconds ahead. So when they meet again, is when the total time that one takes to complete a lap match the two. The total addition of these 4 seconds matches the total time that one takes to take a lap. Because they are doing a 4 seconds difference. So it's how many 4 seconds are there in 72 seconds? That's when they will meet again. And how many 4 seconds are there in 68 seconds? That's when they meet again. Just that Tafara doing more laps. In fact, when him lapping, he's gonna be doing 1 lap more than Nathan. You get me? So the number of laps, number Tafara doing more, right? So Tafara laps. Let's do it here. Tafara. So the time difference. No, the time difference. There are a number of ways to word this out in multiple ways. I must use the four difference seconds, 4 seconds difference. So I'm gonna write out the time difference, right? Time difference. Time difference. per lap is 4 seconds. You want to know how many 4 seconds are there in 72 seconds? Because 72 seconds is the time but one of them take finish a lap. So when they go and meet again, is when one of them, the number of 4 seconds difference equal to the time of one of them take to complete a lap. Right? So Tafara when they meet again. At L. Tafara is lap. Tafara laps equals 72 divided by 4. And when Nathan's lap, and Nathan now have a match the 68 seconds. His 4 seconds deficit have a match the 68 seconds that Nathan is taking, that Tafara is taking. So that's when Nathan's laps equals 68 divided by the 4 seconds difference. Equals, and they work out the two of them. That's the number. It's supposed to be a 1 lap difference between them. Because the difference between these two numbers is 4. So the difference between 74 divided by 4 and 60 divided by 4 has to be a one unit difference. So it is 72 divided by 4, that's 18. So one to 18 laps, and the other one to 17 laps. So Tafara already 18 laps, and Nathan already 14 laps. Let's look at small. So the answer for this is 18 laps, 17 laps. Nathan taking more time to complete the laps and going slower, so it's going to take less laps when they meet again. That's one way to do it. There are multiple ways to do this. But I think this may be the simplest way to kind of explain it. So there's a 4 seconds difference on each lap. Right? So you want to know how many 4 seconds is in the time to complete a full lap. Because that's when they will meet again. Understand? That's what it is. That's it. How many 4 seconds is in the time for a full lap for one of them? All right. Next question. Number 7. Pattern question. So this thing kind of get us this. So these things are to be shaded. It's like some 7. Some keyboard like a 7. You see it? All right, let's look at the pattern. So we keep adding one more box on the horizontal here, so. We keep adding one more box on the horizontal. From this to this, they add one on the horizontal. They add one more on the horizontal. So how many boxes are there on the horizontal? 1, 2, 3, 4, 5. So we must need 6 on the horizontal now. So we go to 1, 2, 3. Then we go to 1, 2, 3, 4. Then it went to 1, 2, 3, 4, 5. All right, that's on the horizontal. On the vertical, no. So like you have 2 on the diagonal under this line then 3 on the diagonal under this line, and then 4 on the diagonal under this line. So we will shade this again. We need to shade this again. All right, so I want us to draw the next shade. So they have top line, let's do the diagonal first, right? You can see where the top line is. So we have 1, 2, 3, 4. So we need 5 now for the top line. So let's put it here. 1, 2, 3, 4, 5. And then we have the top line. This is the top line. How many we have on the top line now? It's 1, 2, 3, 4, 5. We need 6. So it's 1, 2, 3, 4, 5, 6. So we're starting out here. So I would say that's the next shape. But can I agree with that? That's all. Don't it? Look like it? All right, so on the top line, I'll make sure we have 1, 2, 3, 4, 5. So must have 6 now. 1, 2, 3, 4, 5, 6. Good. Then below it, we have 1, 2, 3, 4 below it, and the diagonal below it. So we have 1, 2, 3, 4, 5 below it. All right, that is the correct shape of figure 4. Obviously, that is it. But good? Simple as that. All right, next one. It says the number of colors, the number of colored squares, C, the total number of squares, E. So remember, you have colored and shaded squares. And whenever we do the thing up here, say, we'll start work. So the group below shows the first 3 figures in a sequence. Each figure is made up of a set of small squares of unit length, are both colored, shaded and white. Okay. So you have shaded and white. Now each square. When I each square, you have shaded and you have white. So we should actually draw in the square, you know. We should actually come and draw in the square right there. So we draw the square here. So we should draw the square. So inside the square, you have the shaded and the thing there. All right. Shall we draw inside this? These are squares. Let me draw in these squares out there. Draw them in. They have colored and I could say shaded and unshaded. I could say colored and white. All right, that is it. All right. All right. And I give us the first 3 and we'll draw the 4th one. All right. So that finishes that. The only yes or no says the number of colored squares and the total number of squares. So remember the total, the colored and the white to give it the total, right? And the perimeter P follow a pattern. So the pattern table below and answer the question that follow. Complete the rows mark 1, 2, and 3 in the table. All right, let's look at the pattern. As usual, I like to fill out this line first because it helps us with the lines above sometimes. All right, so let's look at the pattern for here. So this is clearly going up by 2, plus 2, plus 2, plus 2. So because they're going up by 2, formula starts with 2n. First figure is 5. 2 times 1 is 2. So if I add 3 to get the formula for that, so it's 2n plus 3. Then here, he's going up by what? 4. That's a plus 4. Consistently going up by 4. So the formula starts with 4n. There's 12 up there. 4 times 1 is 4. You have to add 8. And then these now is a formula. So look at it. You have the figure number here. So that's the n. Starts out with the n. Plus is always plus 2. And then you square it. So it's n plus 2 squared is the formula. Simple as that. All right. Let's pull out for 11. For 11. So for 11, we're going to put 11 on here. Becomes 2 times 11 is 22. 22 plus 3 is 25, right? This becomes 2 times 11 plus 3 using the formula. That's 25. All right. And if you try the 11 here, so it becomes 4 times 11 is 44 plus 8 is 52. Yes. Then over here now, we're just going to put the formula. So it becomes, if the 11 I put it here in the formula. We're going to remember what it is. So I must always put what it is. So it becomes 11 plus 2 squared. That's 13 squared, that's 169. That's correct? And here now, clearly see that the figure number is 23, right? We're not for about none. It's 23. So I'm put 23 right here. We can test it. 2 times 23 is 46. 46 plus 3 is 49. So that is correct. But we need to put the 23 on this formula now. So it becomes 4 times 23. 4 times 23 plus 8. Whatever I go to. 100 flat. All right, man. Just saying 100. So, next part now says, how many white squares are in figure 11? So figure 11 here. So this is the total squares. And this is the white squares. You have to subtract them. You see that? Total is 169. And the number of white squares is 25. You have to subtract them to get the total colored squares. See it? So that's equal to 169 minus 25. Much is that? 144 that? 144. Eh? That's the answer, 144. The number of white squares, the number of colored squares minus the number of the total number of squares minus the number of colored squares. That's what it is. Total minus the color. Give it the number of white squares. That is it. Next question, number 8. Number 8 says functions f, g, and h are defined as follows. So we have those 3 functions. First one, g of x minus 2. We want to take the x minus 2 and plug it in the g function right there. So the g of x minus 2 becomes x minus 2 where the x was squared minus 5. That's the answer. And it's a simplified. So let's expand that. So we're going to expand this first. We're going to get x squared minus 4x plus 4 and then minus 5 out here. So expand a perfect square. Remember, I get 3 terms. First term squared is that. Second term is twice product of the 2. So you multiply these 2 things, you get minus 2x and you double it to minus 4x. And the second term square, when squared, you get a positive 4, second term squared. And then you subtract back this 5 out here. So finally, it becomes x squared minus 4x minus 1. That is the answer. Then I want f to the minus 1 of 11. You can do this multiple ways. I'm going to use a process of finding f to the minus 1 of x first. And then we're going to do f to the minus 1 of the 11. Let's do it that way. So to find f minus 1 of x first, we're going to say f equals this thing, right? 4x minus 1. We're going to inverse it and x becomes 4f to the minus 1 minus 1. Then to make this a subject, we're going to carry over the 1 first and get, let me shift this over. Right. So we'll carry over the 1 first and get x plus 1 and then divide it by the 4. That's your f to the minus 1. I can put in back the of x now that we're done. We can say in purple. Therefore, f to the minus 1 of 11 now. We're going to plug the 11 in this now. Becomes 11 plus 1 over 4. 11 plus 1 is 12. 12 over 4 is 3. So the answer is 3. All right? The other way to do it, but all right, we're doing it this way today. Let's just someone h of 1. H of 1. So what is the h again? The h is p to the x, right? Remember the h of x is p to the x. So this h of 1 first is h of. We're doing the h of 1 first by putting 1 there. So it becomes 3 to the 1, which is 3. So we have h of 3 first. Then the h of 3 now becomes 3 cubed. I put in the 3 in there now. It becomes 3 cubed, and the answer is 27. That's the answer, 27. All right, so the h of 1 is a first, which is 3 to the 1, which is 3. And then with the h of 3 is 3 cubed. All right, put this in my box. All right, that done. Now come to this function now, the quadratic. It says f of x is equal to x squared minus x minus 2. Just complete the table and plot the graph. So remember, the values are symmetrical. And a quadratic function, the values are symmetrical. So I see a 0 right here, and I see a 0 right here. So the left of this value matches the right of this value. So this is -2, that's -2 as well. Then the right of this value is the left of this value, which is a 4. So this value is a 4. And that is so once these x values are in the same interval, increasing by the same amount. So I don't need to calculate nothing, that is it. Just use the symmetric nature of the values. The values are the same on either side of the of any if any one of those variables. Then I'm looking for the symmetry in the values as well. So it can help me the graph. So you see the -2 and the -2, right? So my line of symmetry will be right here. In the -2 and the -2. You can see that the values are symmetrical out this way from that line and out this way from that line. That represents my line of symmetry, which is halfway between the 0 and the 1. Halfway between 0 and 1 is a half. That's the x value at my turning point, is a half. Halfway between 0 and 1. Then to find the y value right here, where x equals a half, I can plug the half in the function. Find what the y value is there. I can actually get it straight off the table right here. So this is f of a half. You know what my y value is right here. F of a half equals, and plug a half in. Look a girl, you can go back outside with your phone. So you can get a half squared minus a half minus 2 equals. Let's do to the calculator quick. All right, so that's what the y value is there. So it's a half square, which is a quarter, minus a half, and then minus 2. That's minus 2 and a quarter. It's minus 2 and a quarter. Minus, then no, minus 2 and a quarter, 7 over 2. 2 and a quarter. 9 over 2. All right? That's my x value turning point. Y value turning point. So that's my minimum value. That's x value turning point. So I have all those values can work with. So that's my turning point. It means that my minimum point has this and this. And this f of my half is my yt value. So my minimum point, xt yt, is a half and minus 2.25. I've calculated when I give it like this. All right? My minimum turning point. I want us to draw the graph. So we plot the points on the graph and draw it. All the points are plot. All right. So we have to scale it up. They didn't give us any scale, we have to scale it up, right? So go from -2 to 3. So let's say this is 1, 2, 3, 1, 2, 3, -1, -2. And for the y value, it's going up to 4, right? So I'm go down to negative, go down to -2. So that's -1, -2, and that's 1, 2, 3, 4. These are the full scale of the graph. 1, 2, 3, 4. That's a scale of the graph. Put on the values, majority per. So -2, -4 is 1 point over here. -2, -2, 4. Sorry, -2, 4 is up here. 1 point is here, -2, 4. Next point is -1, 0. That's on the x-axis right here. -1, 0 is right here. Next point is 0, -2. 0, -2 is right here. Next point is 1, -2. 1, -2 is right here. Note I don't put in the minimum point yet. I don't put in the minimum point yet on the axis of symmetry. Next point is 2, 0. 2, 0 is right here. Next point is 3, 4. 3, 4 is right up here. I'm going to put in this minimum point now. Half -2.25. So the axis of symmetry is this red line down the middle of the graph, right down here. The graph is symmetrical about this line. That's axis of symmetry. Minimum point is on that. I'm going to put on in red. I put on in purple too. So it's -2.25. 2.25. Now, this would be 2.5. Because every line is 1. 2 lines make 1. So it should be 2.5. 2.25 is right here, halfway. So I'm talking about here. Let me draw that axis of symmetry a little bit better. I'll shift it over. See if we can shift it over. That's it. So that is my minimum point. Right here is my minimum point, -2.25. So right here is half -2.25. All right, so draw the curve through those points. I'm just going to draw a curve through those points. That is it. So important thing that to make it come down and turn, guys. Have to remember that what the graph has a vertex point, a minimum turning point. There's a line of symmetry as well, right? A red line here is the line of symmetry. All right, so that's a graph. And they don't want anything else, just to draw it, and that's it. They didn't want anything. Very important that we put in this minimum point. Very important. All right, that's the minimum point. Very important that we add it to the graph. Cannot just put in these and come across here. We'll put in the minimum point to get the full 6 marks. All right, let's continue. Number 9. Number 9 says WXU are points on circumference of a circle. TV is a tangent. That's a tangent. You're thinking of tangent and radius, tangent and chord. It's a tangent at U. That's a diameter. Remember, angle subtended by a diameter is 90 degrees. So that angle right here, so it's 90 degrees. Angle subtended by a diameter is 90 degrees. Remember? And this is an isosceles triangle. It's also an isosceles triangle. That length equals that length, but this angle and this angle is the same. Question says, using appropriate theorem, state 3 reasons to explain why the angle C is 45 degrees. This angle must be 45 degrees. 3 reasons why it is 45 degrees. All right, so let's look at some of the reasons why it is 45 degrees. Firstly, this angle is 90. Because this is the isosceles, then this is 45 up here. And this is 45 down here. All right. All right. So one reason why this is 45, because the angle between the tangent and a chord equals the angle subtended by the chord up here. That's one reason. This angle where it's 45, because the angle between a tangent and a radius here says 90 degrees. So this is 45, then this is 45. Another reason why it is 45. Another reason it's 45. Another reason is 45. Because the total angle on a straight line is 180. Over here is 90. So the two must up to 90. Right? So we'll give them that as well. But before we do that, then we have to populate some of these angles so we can reference them. So populate these angles that I've just marked out and write the reason for them first so we can reference them. So first I'm going to say this angle is 90. I'm going to say this angle 90 degrees because angle subtended by the diameter. All right. Then these two angles equal because the thing isosceles is the thing that triangle. So this angle and this angle is 45 degrees each. And that angle is 180 degrees minus 90 degrees divided by 2 is 45 degrees. Why is that? Because the isosceles triangle total angle is 180, right? So this is 90 because angle subtended by diameter, and then the isosceles, when you say them two angles equal 45 each. All right? So you can write that. This is because total angle in the isosceles is correct. Triangle is 180 degrees. And this angle down here, I say it's at 90 degrees. This. So this angle, 90 degrees, because the angle between tangent and radius is 90 degrees. That's why this angle here said 90 degrees. I'm going to use those now to explain the reasons why this angle now Z is 45. So first I'm going to say it's equal to angle here first, which is angle UWX. So I'm going to say Z equals angle UWX, which is 45 degrees. Because the angle between tangent and chord equals angle subtended by the chord. Because angle between tangent and chord equals angle subtended by the chord. So basically what I'm saying that the angle between this tangent and this chord is equal to angle subtended by this chord here, which is the angle base of 45 degrees. That's why this angle is 45 degrees as well. That's the first angle I'm giving. Second angle, I'm going to say it is equal to 90 minus is 45. This Z is 90 minus is 45 because the angle between this tangent and this radius is 90. So I'm going to say next. So this angle Z is a different color for this answer. Angle Z becomes 90 degrees minus 45 degrees, which is 45 degrees, because the angle between tangent and the radius, that's this tangent and this radius, is 90 degrees. And the angle between tangent and the radius is 90, and inside it says 45 already, and this angle must be 45 as well. Then I'm going to say no, total angle on the straight line is 180, because over it's at 90 already. It's a 45. I'm going to use that as my next view. Let's put that part in blue. So the angle Z now again is equal to 180 degrees minus the sum of the 90 and the 45 here. So 90 and the 45. It's still again, it's another 45 degrees again. That's because angles on a straight line add to 180 degrees. That's my 30s. That's my 30s, 3 reasons I give. All right, but I have to populate some of the angles on this diagram first to help it, to make this reasoning part easier. Let's put out some of the angles on this and put the reason for them on it up here. Then to explain this one now, I already have these angles referenced. Help me. All right, that is it. All right, down here, some circle theory. Question says, in the diagram below shows a circle, the diameter, that's a diameter, diameter subtends 90 degrees, the right side 90 degrees before you start. It says the line EFG is a tangent, that's a tangent. We're thinking about tangent and chord. So this angle equal this angle here, so. And also tangent and radius is 90 degrees. We're thinking of some of those things before you go. And it says points F, H, K, and J lie on a circumference. These points are on the circumference, as you can see. That is it, right? It says, by showing each step in your work where appropriate, find the value of each of the following angles. I just want us to find the values. First angle I want. First angle I want is angle X right here. So that same segment, that this angle X is subtended, as you can see, by this chord. The same chord is subtending this angle up here of 56 degrees. So these two angles equal, same segment rule. So angle X equals 56 degrees. From the angle in the same segment are equal. That's it, all right? Done. So this angle here says 56 degrees. Let's put on the diagram. 56 degrees. Next angle I want is angle Y. Look at it. Angle Y is an angle that is external to this triangle. Because look, if I were to draw in this triangle, And this angle is the angle on the extension of this side. That's what that angle is. That angle Y is an exterior angle of that triangle. Exterior angle of a triangle is equal to the sum of the two opposite interior angles. More things you know, the better. So this angle out here is equal to the sum of this angle plus this angle. Exterior angle of a triangle is equal to the sum of the two opposite interior angles. So put it like this. This angle is the sum of this one and that one. That's what angle Y is, sum of those two. But the exterior angle of a triangle is equal to the sum of the two opposite interior angles. Angle Y is an exterior angle because it's an angle on the extension. So it's equal to the 56 plus the 19. All right, that's what it is. So angle Y is equal to 56 degrees plus 19 degrees. What is that? 75 degrees. What's the reason? Let me have to read it to them. Let's work it over. Let's write it still. That is 75 degrees. Let's write the reason right here. Exterior angle equal to the sum of the two opposite interior angles. The exterior angle of a triangle equals the sum of the two opposite interior angles. Yes? Huh? You find a different way? All right, one now. There you go. Since you know that this is 56. That's why this one. This one? Oh, you find here first. And then subtract from 180. Get this. Yeah, man, that's to the left as well. But he basically saying, you see? He basically saying that he did this. He said he found this angle is first. 180 minus the sum of these two. Right? Then you use total angle on a straight line. 180 to get this one. Yeah, man, that works as well. That's all right. Just that you need 2 steps for that one. But remember, I'm showing is 1 step. But if you do it that way, you get the marks. That's fine. That is fine. All right. That is part one. Question said, diagram below shows 4 points P, Q, R, and S on level ground, where pillars will be placed to mark the outline of a foundation. So a pillar is like a vertical object, right? Well, pillars, right? It says, there is a vertical post RT at R. So right here, there's a vertical post. Remember, these points are on the ground, you know, guys. And the vertical post is standing up in the air. You can't see it because looking at this is like you're up in the sky looking down. Right? So the vertical post right here coming up towards you if you're looking down at this thing, right? So imagine that these 3 points are on the ground and you're up in the sky looking down at this. So the vertical post right here, you cannot see it. To see it, you have to basically imagine that right here you have a vertical post. So I'm going to draw it like this now. And right here is R. And up here says T, vertical post. And what they gave was the angle of elevation of T from Q. So from Q to T, angle of elevation is 21. So on the same horizontal ground as R, you have the point Q. So on this now, I'm going to put the point Q out here so you can see it. And put the point Q out here, so. And angle of elevation that spoke about is angle of elevation looking up here. And this is the angle of elevation, which is now 21 degrees. But just as on this diagram, the distance from Q to R is 153. On this diagram, it is also 153 meters. That's a diagram. If you look at it from the side, right? Just that they cannot see this up here, but that's a plan view. It's what we call an elevation view. Like you're standing to the side and you're looking at it like this. Standing to the side. If you're on the ground looking at it to the side, that's what you would see. All right? That's what you would see. So that is the diagram. So to pull it out. All right? It says must calculate the height of the post. That's what they want. Height of that post. Let's call it H. So asking us to find this H over here. H. Height of the post H. So when you use tan equal opposite over adjacent. Simple as that. Tan equals opposite over adjacent. Let's go back for the blue. So I'm going to use tan of 21 degrees equals the height H over the adjacent of 153. To find the H, we're going to take the 153 and multiply it over here. So you're going to get 153 times the tan of 21 degrees is equal to the height. Therefore, that height equals, when I wrote this out to the calculator now, write that out to the calculator. So it's 153 times the tan of 21 degrees. That's 58.7. 58.7 meters is the answer. 58.7 meters. That is it. But good? But all right? Good. Next question says, given that the length of 2S is 135, I didn't put on the diagram. 2S. If this length is 135, let's put on the diagram. So this length is 135 meters. Let's calculate the perimeter of the foundation. So the perimeter of the foundation is distance all around. But this length, we should know, plus this length, we should know, plus this length, we should know. We need to find this length. We don't know it. To get the perimeter. That's it. We need to find PS. We need to find PS. So to find PS, we're going to come and work in this triangle and use cosine rule. See that? Because we have two sides and an angle between. So we're going to use cosine rule to find PS. Cosine rule to find PS. This triangle. Let's do it over here. So we're going to use cosine rule for PS over here. So cosine rule for PS. Because to get the foundation perimeter, you have this length plus this length plus this length. You need to find this one. We don't know it yet. So when we find this length, we'll add up all of these with the PS, I'll get the perimeter. So we need to find PS. So when I work in this triangle to find PS, which is cosine we'll have to use. So it's going to be that PS squared equals, remember it starts out like Pythagoras' theorem. So PS squared equals this side squared plus this side squared, which is the 83 squared plus 135 squared. They subtract a piece. They subtract 2 times the 83 times the 135, and they cosine the angle between them, which is 29 degrees. 29 degrees. Let's shift this down. It's smaller. That's what you're doing. And then to find the PS, we're gonna just take off this square and square root this side. Cross out that square and square root everything here. So we can do one calculation and get the PS that way. So calculate the PS with one calculation here. So they become the square root of 83 squared plus 135 squared minus 2 times 83 times 135 times cosine of 29 degrees. I'm getting 74 meters. Let's put it back in meters. Everything is in the nearest whole number, 74 meters. So the perimeter becomes some of these things now. This plus this plus this plus is 74. I cannot do it right here, so I never carry it out. Let's do it right here, so I never carry it out. So the perimeter equals 110, as this, plus 153 plus this 83 right here, so plus the PS, which is 74. I'll put the 74 in here, so. So this side equals 74. I move this first. That's how we're working. So I'm going to copy these down the next page and put them where you want them. Down here, so. So this was the PF calculation, and this is the final calculation. Put this under here, so. Equal, add them up. 110 plus 153 plus 83 plus 74. That's 420 meters in the perimeter. 420 meters. The PS was 74. That is small. All right, that's that. Question done. Last question for today. Last question. Let's go. Let's go. Next question. Matrices. Question says 3 matrices QR and SR as follows. That's a 2 by 2. That's a 2 by 2. That's a 3 by 2. 3 rows, 2 columns. That's a 3 by 2. Question says explain why the matrix product QS is not possible. Not possible because they are non-conformable. So what is going to be QS? So the Q is a 2 by 2, 2 by 2. That will be a 2 by 2, a 2 by 2 times, and the S will be a 3 by 2, a 3 by 2. That will be a 3 by 2. But these numbers not equal. See, the number of columns here and number of rows here are not equal. Means that is not conformable. The number of columns in the first matrix is not equal to the number of rows. The second matrix, we say it is non-conformable. Non-conformable. They are non-conformable multiplication. And that's the reason. That's why I thought number of columns in the first matrix, which is Q, is not equal to the rows. Number of rows in the second matrix. See there? The reason, explain why. Because the number of columns in the first matrix, which is the Q, is not equal to the number of rows in the second matrix, which is the S. means that they are non-conformable. That's what happens when they're non-conformable. That's why it can't multiply. The number of columns in the first matrix is not equal to the number of rows in the second matrix. They are said to be non-conformable. All right? Next one. State the order of the matrix product SR. That's S times R. If you turn them around, S times R. So S times R, the S would be at 3 by 2, and the S is at 3 by 2, times, and the R is at 2 by 2, times 2 by 2. So this one conforms. So you're good to go with that. The result is going to be this number of rows by this number of columns. That's a resulting order. That's 3 by 2 is the result. That's the answer. 3 by 2. That's the order. 3 by 2. When it is conformable, the result will take the number of rows on the first one and put it with the number of columns for the second to get the final order. That's what I want here. 3 by 2. What go with that? The resulting order. Let's want to calculate the matrix product QR now. Q times R. Q times R. Now Q is 2, 2 negative 1, 3, 0. 2 negative 1, 2 negative 1, sorry, 4, 3. 2 negative 1, 4, 3 times R is 1, 6, negative 5, 4. I'm multiplying these two matrices now. Remember, when we multiply matrices, we're using the rows of the first matrix with the columns of the second matrix. And the result is going to be a big 2 by 2 matrix with 4 values. The first value here is positioned in the first row and the first column. So to get it to multiply this first row with this first column, we multiply the first element in the row and the first element in the column, second element in the row by the second element in the column. So it's first element times first element, second element times second element. First element times first element, second element times second element. 2 times 1, and the negative 1 times negative 5. 2 times 1 is 2. Negative 1 times negative 5 is a positive 5. And the second value here is positioned in the first row, second column. So to get it, you multiply this first row with the second column. Same thing again. First element times first element, second element times second element. First element times first element, second element times second element. 2 times 6 minus 1 times 4. 2 times 6 is 12. Minus 1 times 4 is negative 4. And this value now is positioned in the second row, first column. So to get it to multiply this second row by this first column. And it is first element times first element, second element times second element. First element times first element, second element times second element. 4 times 1, 3 times negative 5. 4 times 1 is 4. 3 times negative 5 is negative 15. And the last value is positioned in the second row and the second column. So to get it to multiply this second row by the second column. Again, it is first element times first element, second element in the row by the second element in the column. First element times first element, second element times second element. 4 times 6, 3 times 4. 4 times 6 is 24. And the 3 times 4 is 12. You're going to write the final result. becomes equal. The 2 and the 5 is 7. 12 minus 4 is 8. The 4 minus 15 is negative 11. 24 and 12 is 36. That's his answer right here. What after that? Good. Now come down to this part. It says they give us this matrix and they tell that the determinant is 5. This means the determinant is 5. Must find a value of this. So the determinant of A is equal to 5. What is the determinant? It is this product minus this product. So this product is 4 times x, which is 4x, minus this product is negative 1 times negative 7. Negative times negative is positive 7. So you're subtracting a 7. That's equal to 5. You're solving for x. You know what the 7 first, you get 4x equals 12. You divide by the 4, you get x equals 3. But go to that, you care about the 7, you add it to the 5 and get 12. You divide by the 4, you get 3. Next question. Last thing on the day. It says, in the diagram below, OPQ is a triangle. It said ARB and AOQ are straight lines. Everything that's saying up here is on the diagram, right? These are straight lines, It says B is the midpoint of PQ. So B is the midpoint of this line. So this length and this length is the same. That's obvious. And it says R is the midpoint of this line. So this is the midpoint of this line. So this length and this length is the same. It says OR to RP is 1 to 3. So OR to RP is 1 to 3. So it means that R divides this line in the ratio 1 to 3. Let's put on the diagram. It means that this part of the line is 1 part. This part of the line is 3 parts. The total parts on this line is 4. So this is 1/4 of the whole line, and this is 3/4 of the whole line. 1 to 3. Then it tells us that OP, the whole of this line, is 4A. So the whole thing is 4A, and it is in the ratio 1 to 3. It means that this vector down here so is 1A, and this vector up here so is 3A. But the whole vector is 4A. But I can understand that? All right, so the ratio of the line is 1 to 3. 1 to 3. This part of it is 1 part. Down here so is 1 part. Up here says 3 parts. See there, 1 to 3. OR is 1 part. RP is 3 parts. RP is 3 parts, right? Good. So it means that the total of this line is 1 to 3. 4 parts. That line of 4 parts. 1 part down here and 3 parts up here. See that? So the whole of the line is 4A. The whole of the line is 4A. And it's a 1 part and it's a 3 parts. It means that if the whole line is 4A, then the vector from here to here is a 1A, and the vector from here to here is 3A. Because the total line is 4 parts anyway, and 4A divided into A plus 3A. See that? Good. So they give you a nice, easy numbers to work out. So it means then that the vector here, so in the 1 part, is 1A, which is just A, and the vector up here for the 3 parts is 3A. So the total vector will be 4A. A plus 3A is 4A. So the ratio is divided nicely for you, the 1 to 3. And then let's say the vector OQ is 8B. So this vector out here, so now is 8B. So right here, so is 8B. Remember, at this level now, vectors are about how you get from point to point. Right? Just want to see how you go around the diagram from point to point. Remember that 3 a little smaller. The ratio. We don't need it again, you know. Right? All it helps us to divide this vector 4A into A plus 3A. That's all it did help us to do. that ratio of 1 to 3. And then we always give a nice easy figure like this. Then we want the vector PQ now. P to Q. You can look at the diagram and say, okay, you go from P to Q, I'm going to come minus 4A plus 8B. You can see that? Or because you know the two portion vectors, you can use O times the last minus O times the first. Now, when you know the portion vectors, you can do that. So PQ is OQ minus OP. O times the last minus O times the first. The OQ is 8B. That's 8B. Minus the OP is this, 4A. 4A. That's the answer. Simple as that. That's what PQ is. Next part wants us to find PR. So P to R. So see now P, sorry, P to R. It's just minus 3A that. See there? P to R, just minus 3A. Minus 3A. Can I go in the opposite direction to 3A? So P to R is just minus 3A. That don't need no calculation. It's clear in the diagram. That's P to R is just minus 3A. Go in the opposite direction to 3A. Go from P to R. See there? P to R is just opposite direction to 3A. So it's minus 3A. Simple. That don't need no calculation. Then I'm on RB. Go from R to B. Let's look at the diagram. To go from R to B. Now remember, we know PQ, you know. So we now know this road. We know this road. We know the full length of the road. So we can go part of it as well. So we go from R to B. We can go R to P first, and then go P to B. Let's try it out up here, so let's work it out up here, and then we'll copy it out. So let's do it up here, so on the screen. So when I said to go from R to B, based on the diagram, we're going to go R to P first up here, so. And then we're going to go P to B down here, so. But the PB is half of the PQ that we just found a while ago. So we're going to go R to P, which we know is 3A, plus half of the PQ. Because we know the PQ is this. So the RP is 3A, and then half of this becomes 4B plus minus 2A. Half of PQ is half of this, which is 4B minus 2A. But understand that? That's what the half of PQ is, half of this. So this works out then. Let me make this right, it's a bit better. So it becomes 4B is 4B, and then 3A minus 2A is A. That's the answer for RB. Let's copy this down. Done. That's the answer. There we go. I need to know much again. And that is end of this test. Come on, let me hear how much I get. People online, I want to know how much I get too. I want to know how much I got. Come work out and tell me how much I get. Remember the fast market, 65%. Let me hear. Huh? Much I get? Sit down and work out and tell me now where I go. No, no. I want to hear how much I get. I want to right, this never recorded. So, huh? Let me go on to. Is it never can of course what I do? Unless it's somebody else. Personal. And you now and next never record. Huh? How much? Alright. Am I record? See that? Good. That's good. That's good. That's good. Come, guys. Work out and tell me what you got. Come here, little girl. Where you going? Come here, the two of you. Come here, man. It's unruly. Come here, where you going? Yeah, so much you get. Yeah, you want to tell me that is no problem with that. So you know how much you get. Probably where? I'm gonna go and chat. Come how much you get. So you know you have to do. You have to go and rough it about the first time. I'll send a video in the group. So you shot this. I send the video in the group. And you go back to and do the system and get wrong. I have to do for next week. I'm moving fast, man. In fact, we do another paper. We do a paper Wednesday. We do a paper Thursday. Yeah, only day. All right. So make sure you go to the system and get wrong. I have to improve on this year. 61. You sharp by 4%. Go back over the question then. Go back over the question. Make sure you attain the 65% before the week is out. So I do paper tomorrow. Until the paper for tomorrow, make sure you do it. You were doing the paper that you were supposed to do at home, the other paper from yesterday. I sent it to the group and tell you before tomorrow. All right, maybe start. So, I'm on the session. Guys online, what's up, how much you got? People online, what's up, how much you got? What's up, how much you got, Jadine? I miss Abbott. What's up, how much you got on the paper? Remember, you have another one for tomorrow. I'm going to end the session now. Send me a WhatsApp of what you got, please.